as stated yesterday, we're going to learn about scientific notation and radicals today. So with scientific notation, the number has to be between 1 and 10. So if I'm looking at this as kind of like, it always comes out to be like something like this, times 10 to the 8th, or 2.6 times 10 to the 12th. So if we're looking at this, if the number has to be between, that is 6, is an awkward spot. So if the number has to be between 10, like 1 and 10, that's what it has to be, or 0 and 10, no, 1 and 10, 1 and 10. Has to be between 1 and 10. This number is between 1 and 10, so this is perfect. We don't have to do anything with it. This number is not between 1 and 10, so we have to switch it. So technically our decimal is here, so we're going to move it back 1. So now it's 1.4 times 10, and since we moved it back this way, scientific notation is a little weird. When we move it backwards, it's actually going more positive. So it's 10 to the 9th. When we move it this way, it's actually going more negative. Okay? But what does scientific notation mean? People get a little confused with what scientific notation means. So, with scientific notation, if I'm given 6 times 10 to the 3rd, basically this means what I'm doing is actually adding 3 zeros. That's what this to the 3rd means. It's just a shortened way of writing a big number. Because you don't want to write all those zeros out, especially if we get a number like this. Do you want to write a number that is, I'm trying to find a really big one. Do you want to write something like this? Do you want to write something like that out with 50 zeros? I don't think so. I wouldn't, personally. That's a lot of zeros. So this is why scientific notation is around. Because all you have to do is say, well, there's 50 zeros, so let's just do 4 times 10 to the 50th. That's so much more simpler than writing the whole 50 zeros out, which will take basically your entire paper, right? So it's so much easier. That's why I like scientific notation. It's a little easier to write things. But let's say we want to actually, we have or we're given a number here. This is where some kids get a little confused. Because we're given this number. That shouldn't be a decimal yet. So we're given this number and we're asked, let's move this into scientific notation. And like I said a minute ago, if we're moving this way, we're going positive. If we're moving this way, we're going negative. We need to make it a number between 1 and 10. So what we're going to do is we're just going to take this decimal until we reach a number between 1 and 10. So 1, 2, 3, 4, 5. Because 2.031 is a number between 1 and 10. So I'm going to write this down. Times, since it's scientific notation, it's always 10. And then how many spots did I move? Well, I moved 5. But since I moved this way, I moved negative 5. So now I've written that equation, or that problem, whatever it is, into scientific notation. And that looks a little simpler than this one, right? So that is how we move things into scientific notation. It's relatively simple. So now we're going to learn how to add and subtract with scientific notation. This is where things get a little bit more complicated. But just remember this little important thing. I always, when I get my homework, or when I get, because I was doing all the homework that the kids had, because I needed answer sheets for myself. So when I got the homework, I'd be always putting this at the top of my worksheet, where I was like, this way is positive, this way is negative. If it's helpful for you, I would do it, because that's super helpful for me. So if we're given an equation kind of like this, we're given 9.5 times 10 to the 11th plus 6.3 times 10 to the 9th. When you are adding and subtracting scientific notation, the only way you can do that is if the exponents match. So right here, the exponents aren't matching. And for me personally, I like to try to keep it where I don't have to change it in the end to fit and move it backwards again. So with this guy, I want to make it an 11. And to make it an 11, to make it bigger, I have to come this way. And how many spots do I have to move to make a 9 and an 11? Well, I need to move 2 spots. So I'm going to do 1, 2, put a 0 here. So now I have 0.063 times 10 to the 11th. Now I can add that to the 9.5. We know that the end of this is going to be 10 to the 11th. But now we're just going to add 9.5 plus 0.063. And that's easy, which gets us to 9.563. And we have just added scientific notation. We just have to move it to make sure that the exponents are matching. That's the whole goal of scientific notation, adding and subtracting. You have to make sure that these are going to match. You can't not match them. It's kind of a rule when you're adding and subtracting. So let's find one that's a subtraction, shall we? So if I'm given 1.03 times 10 to the 9th minus 4.7 times 10 to the 7th. So let's look at this guy and we'll be like, okay, so I have a 9 and I have a 7. I always try to go and make it match the bigger number because it usually makes this one easier to subtract or add. So to make a 7 and 9, to move 2 spots. 1, 2. Right? So now this is a 9, so times 10 to the 9th. And 0.047. So now we're just subtracting. So to subtract this, this actually turns out something a little different. So if we're subtracting this on our calculators, we're actually going to get 0.983 times 10 to the 9th. Well, our problem here is this is not a number between 1 and 10. Or 1 and 9. 1 and 10, yeah. 1 and 9, something like that. It's got to be a number between that. 1 and 10. Okay. Just follow along with me. It's fine. So this is not a number between that. Right? So we have to fix this. So how do we fix this so it's a number between 1 and 10? Well, we can't go this way or it'll make it even more. So what we have to do is go the other way. So if we're going to go this way, 1 spot, since we're going that way, this makes it go down. And now it's 9.83 times 10 to the 8th. Always make sure that you move it so it is a number between 1 and 10, or 1 and 9, whatever it is, right? And make sure you're using this this little thing right here, this little cheat sheet. I call this a little cheat. I like it. It makes sense to me. And then make sure you always change the exponent to whatever you did. If you went this way, it goes down. If you went this way, it went up. That's adding and subtracting. It's really relatively easy once you figure out which way you're going. Okay? Let's try one with a negative number in the exponents. Dropping my eraser. Which kind of confuses people sometimes too. So if we're given given, I know how to speak English. 7 times 10 to the negative 15th minus 4 times 10 to the negative 17th. So if you're looking at this, you see, well, in your mind, you're probably thinking, well, 17 is bigger than 15, right? So you'd want to move this guy. But when we're looking at negative numbers, 15 is actually bigger than 17. So which one would I actually want to move? Personally, I want to move this guy because I want to make this a negative 15. And to make it a negative 15, I have to move it this way because I'm going positive. And so I have to move it positive 2 spots. So now it's 0.04 times 10 to the negative 15th. And now we just subtract. And subtracting 7 minus 0.04 gets us to 6.96 times 10 to the negative 15th. So negative numbers aren't even that hard either. They just kind of confuse you because you're thinking, well, this guy's bigger. But since it's negative, technically that guy's bigger. You just have to use some common sense there. I know, common sense sometimes is, hard. I get it. So now let's move on to some multiplication and division of scientific notation. So multiplication and division are actually easier than addition and subtraction. Did you know that? So if we're given 3.9 times 10 squared times 2.3 times 10 to the 6th. So with this guy, all I'm going to do right here is I'm going to multiply, because the bases don't have to match in multiplication. They don't. Multiplication and division, your bases don't have to match. And the exponents don't have to match. Bases always have to match. The exponents don't have to match in multiplication and division. All we have to do right now is let's multiply the 3.9 times the 2.3. And what you get is 8.97. And all you have to do with the exponents is add. What's 2 plus 6? 8. That's all you have to do with multiplication. Just multiply the numbers, add the exponents. That's it. And then if you have to move the decimal, move the decimal. Okay? Really relatively easy. So if we're looking at one of these division ones, so if we had to add the exponents in multiplication, what do you think we have to do with the exponents in division? So let's divide the 9.45 by the 1.5, and I get 6.3. So if we were adding in multiplication, we are subtracting in division. So 10 minus 6 is 10 to the 4th. That's it. It's pretty easy, right? I like it. So that's just pretty much what you have to do in this. Just addition and subtraction is a little bit difficult, a little more difficult than multiplication and division. Mostly because you have to move things to make them match. This one you don't. Just add and subtract. That's it. That's why I like that one. So now we get to move on to one of my favorite things is our radicals. Radicals and roots. So if we're going to make some factor trees, so I'm given this. I'm given these 3. And they want us to make factor trees. Well, factor trees pretty much look kind of like this. We're breaking them down. We need to break down the numbers into the prime numbers that make up these numbers. So with an 8, what can we multiply to get an 8? Well, I know that it can be multiplied by 2 and a 4. I can't break down a 2 anymore, but I can break down a 4 even more to a 2 and a 2. So now I have broken down my 8 into all of its prime numbers. This is an introduction to how we're going to break down radicals when we need to. So now with the 640, let's break it down into its roots, or into its prime numbers, because we have to know how to do this. So with this guy, I know it breaks down to 8 and 80. If you don't know what it breaks down into and it's an even number, you can always just go down by 2s. Yeah, it takes a little bit longer, but sometimes I don't know what it breaks it down into, so I tend to go down by 2s when I don't know. And especially if I don't have my calculator and I'm not really allowed to have a calculator, I just go down by 2s. So, well, we already know that 8 breaks down into 2 and 4 and 2 and 2. So with this 80, let's break it down. Well, it goes down to 8 and 10. And we know that 8 also breaks down to 2 and 4 and 2 and 2. And the 10 breaks down to 2 and 5. So now, this has been broken down into all of its prime numbers. Because that's our goal. Break it down into prime numbers. So if we're going to break down 144, I know that 144 is 12 times 12. Well, let's break down 12. 12 can be broken down. We can break it down into multiple things, because I could break it down into 6 and 2. So I'll do that on one of them, and then I'll break it down into the other one. So if I do 6 and 2 on this guy, but then I can also do 3 and 4 on this guy. So 6 and 2, 6 also breaks down to 3 and 2, and 4 breaks down to 2 and 2. So even when I break it down into 6 and 2, I still am left with 2, 2, and 3. When I break it down into 4 and 3, I'm also left with 2, 2, and 3. So it doesn't matter which one you use, because you're still going to be left with the exact same one, because we know that that's what 12 breaks down into, right? Hi. I can't hold you right now. I can't. Don't climb up me, please. Please don't. Okay, we're walking apparently. Okay. So that's the basis of breaking things down into roots. Ow. That hurt. So, knowing that, this is just an introduction to roots and perfect squares. So most of the stuff on this worksheet is all going to work out fine. You can plug it into your calculator. But you should probably, what the best idea is, that what we learned at the school is you need to make sure you know your perfect squares that from 1 to 20. And you need to know what they are. So you need to know, well, the square root of 400 is 20. 20 squared is 400. You need to know those. Memorize from 1 to 20. That's a goal that you need to set for yourself, because those are the most important ones. Okay? That's one of those main goals that you need to work on. So I just wanted to teach you how to break things down into roots, because that's going to be important coming up here. Yep, right here. So, if I'm given something in a radical, this is what we call a radical. It's this little square root thing. And I'm given 32. Over here I'm given 40. And over here I'm given 99. So, I'm going to look at these. These are not perfect squares. So we have to break them down to their prime numbers and see what we can pull out. So, with 32, I'm going to break it down. I know 32 is 4 times 8. Well, let's go down further. I know that we can break it down into 2 and 2, 4 and 2, and 2 and 2. Okay, when we're breaking things down and pulling things out, we can only pull out pairs. That's all we can pull out. So looking at this, I have a pair of 2's here and a pair of 2's here, but I'm left with this 2 that's just going to chill underneath the radical because I can't pull that guy out because there's not another 2 to pull out. So I'm going to write a radical and pull this 2 and move it here. But if I'm pulling a 2 out here and a 2 out here, technically it's 2 times 2. Well, what's 2 times 2? 4. So my final answer on this guy is 4 square roots of 2 because I've simplified it. So the square root of 32 simplified is 4 square roots of 2. That's how I do things. So now let's look at the square root of 40. The square root of 40 can be split into 4 and 10. 4 can be split into 2 and 2, and 10 can be split into 2 and 5. Well, where's our pair? Our pair is right here, which means we're pulling a 2 out, but we don't have another pair. So I know I pulled a 2 out. So we have to multiply these 2 back together, which is 10. So it's 2 square roots of 10. That's it. So now with the 99, I know 99 is 9 times 11. And 9 is 3 and 3. 11 I can't do anything with. But the 3's I can pull out. So I pull out 1 3 because a pair technically means you're pulling out 1. So I know that I'm left with a 3 on the outside and 11 on the inside. So 3 square roots of 11, that is simplified. Because you're going to need to know that when we